Hello and welcome back to my video series on doing WebGL programming. Today we're going to be modifying the last thing that we did in the last tutorial to be adding this textured little cube image that I found on the internet. Nice, public domain, isn't that great? We're going to be applying that to our spinning box that we had in the last one. Now, I know in the last tutorial I said that it was going to be shorter than the first one, and I lied pretty heavily. This one, I'm not lying, it's going to be a lot shorter. So if you're jumping into these tutorials now, you can download the code on GitHub. I've put it up on on the description, and there's a commit for every one of these video tutorials. Yeah. So I found this image, public domain. It's really nice. I like to release my stuff under public domain usually. There's the MIT open source license, that kind of thing. So I just grabbed this image and I downloaded it for the sample right here. I already have something working, but I am going to be building off of the code that I used before. So let's first off just grab this image really quick. This is the directory that I'm storing everything. So I'm going to call this crate.png. Cool. So now that I've got that downloaded, let's talk a little bit about how texturing actually works. So if you remember from the last time, what we had is we had a box rotating around. Let's actually pull that up. So this is the actual code that we loaded from last time. It's just a colored cube rotating around. And if you remember, each one of these faces has two triangles on it that forms it. And it kind of has like a little diagonal across that you can't see because the triangles are right together. So what we're going to do is we're going to map every single one of these triangles on that image to a different part of this image. That's the way texturing works in 3D applications, is every single triangle you map it on here. For this tutorial and for this, it's going to be either we're going to do the upper diagonal over here, or we're going to do the lower diagonal over here. So if I were to open that image up in Paint, that's oops. You can see all the failed drafts of this video, usually a few seconds before something happens. And I realize, oh, I'm not recording, or oh no, shoot, something's going wrong. We have this under game programming. Right here. Edit. So I'm just going to pull this up in a Paint window. So the way texture mapping works, I found a couple of things, and I'm going to put these resources up on the description. I found a Stack Overflow post where someone else was asking how to OpenGL texture coordinates work, and then I found a nice little article here about actually applying textures to objects. So I'm just going to skim over these briefly. If you want to read them more in depth, the links are in the description. So the way the texture mapping works is every vertex you are going to give a texture coordinate, and the texture coordinates work in XY space, kind of. They call it UV space, and sometimes even ST space for whatever reason in OpenGL. And very similar to how our OpenGL canvas here works in the space from -1 to 1 and -1 to 1 instead of the actual number of pixels, texture spaces do the same thing. It works from 0 to 1 on both the U and V axis. So you will give each vertex a point, each vertex of every triangle a point in UV coordinates. So this one, for example, has point 0, 0, 1, 0, and 1, 1. And when the triangle is rasterized, it will grab for every fragment a pixel or a group of pixels from the image, and it will apply them to the triangle. So you can see right here the example they gave. The triangle was skewed a little bit. So it was, what is this called? Is that an isosceles triangle? No. Scalene? Who remembers? It's one of these triangles, and you have an obtuse angle right here, so it goes across, and you can see that the image is stretched accordingly. So that's pretty good to look at, I guess. And then for the actual sampling, in the rasterizer step, every fragment will get a point between these 0 and 1s for where that pixel lies on the image. And you have a whole bunch of different options. So up here it's just talking about wrapping. This is what happens if you give it a value outside of the range 0 or 1. So what it can do is OpenGL can just kind of interpret it as repeating, so it more or less modulus, applies a modulus operation to it, repeats the image. You could do a mirrored repeat, which is really nice for like brick wall kind of textures. A clamp to edge, which just takes whatever that corner pixel is, that value, and extrapolates it all the way out. Or a clamp to border. We're probably just going to use clamp to border to make it easier on debugging. The more important thing, though, is filtering, and this is how the color of a fragment is determined. So in this example, you have an original image that's super tiny, maybe this big, and it's stretched out on a very large rectangle. The number of fragments that are going to be generated are not going to be one-to-one with the image size. And so there are several different options you have. Nearest, which just gives you the pixel nearest to the coordinates that you found. Linear, which returns a weighted average of the 4 pixels surrounding the given coordinates. And then you have all these bitmap options, which we're not going to worry about bitmaps now. If I get to more advanced tutorials, we might talk about bitmaps. More or less, it's just a level of detail adjustment that the graphics card is able to do. It's a really cool level of detail adjustment, but not one that's important for this tutorial. Alright, great. So I'm going to move these off to the side. We will need that paint window later. And I'm going to pull up my code right here. And as you can see, this is just the code that we left as we left it behind in the last tutorial. All the vertexes, all the this. I hope you can read it. I'm using a pretty high resolution monitor right now, and I'm targeting you to be able to read this on a 780p display. Hopefully that works. Let's see. Don't need that. Won't need that. Let me just refresh this and make sure that the server shut down. Cool, good. Oops, oh dear, that's probably really loud. Apologies. Great. So the first thing I am going to do is let's get that image in here as well, just to make sure that I load it properly. Image source equals create.png / image. Great, we have an image. Let's give it an ID so we can reference it later. Create texture image. So one of the cool things about doing WebGL programming is you have access to all of the nuances of JavaScript and the DOM and HTML5 and browsers. And one of those things is you have a built-in image library that takes care of the rendering of image, finding out all the information about images, so you don't have to do any crazy, linking to image libraries like you would normally if you were doing OpenGL or DirectX programming. You can just do this. You can grab an image. So let's make it invisible, because I really don't want to look at it, in addition to our spinning cube, width equals 0, height equals 0. If we do that, great. So now we can't see it, but it's there. So let's go back over into our JavaScript now, and we'll make the changes that we need to do. Let me just grab my notes here. So the first thing is, in the other spinning cube, we are no longer using vertex colors. We are now going to be using texture coordinates, because we're using texturing instead. And in the texturing, we don't use 3 numbers, we just use 2, the U and the V component. So I'll call that vertex coord. And then likewise, on the fragment, we're not passing a fragment color, we're passing a fragment text coord. And that just stands for texture coordinate. Great. So let's change these variables. We are doing the same thing where we're just passing that texture coordinate from the vertex shader into the fragment shader. We're not doing any processing on it in the vertex shader. And then the position, we're not changing that. We're only changing the coloring information. So in here, let's change that and that. So you can see what we were doing before is we were just saying the fragment color equals whatever the fragment color was before. We're not going to be pulling straight from the texture coordinate, obviously, just those 0s and 1s. We are going to instead be sampling an image. And the way that we do that is we use a sampler. And you can specify that as a uniform sampler 2D. And I'm just going to call mine sampler. Let's separate those. Great, so these work a little bit differently than the uniforms that we have up here. Normally in Fragment Shader, the uniforms work the same way, where you have your, your get uniform location, your uniform matrix 4VF, or your uniform 2 whatever. But with the samplers, you don't do that. They just, as they appear in order, you use them as such. So this sampler is going to be texture 0. And this is the sampler that grabs information from texture 0 as it is applied to the graphics card. And we'll cover that more in just a minute. So to get the actual fragment color from that, we use a special function called texture 2D, which grabs information from a texture 2D. Which texture 2D are we using? We're using sampler, that texture 2D. And what texture coordinate are we using? We are using the one passed as the texture coordinate to this fragment shader. If we refresh it right now, I don't know what it'll do. Let's find out. Great, so it's at least running still. The shaders are compiling properly, so the shaders work, even though you can see it's giving us a couple of errors because we're still using the old values, the vert color and all that. So let's actually hop straight to that. 178. Great, so you can see in here our vertices are still going to be using the RGB values, and so we need to fix that. Indices we aren't going to have to change, and then all these attributes we are going to have to change. So let's start out by changing the attributes actually. So we no longer want to use a color attribute, we want to use a text chord attribute, which, oh, look at that, look at how beautiful that is. Same lengths. Great. The position is remaining unchanged with the exception that we are going to use 5 elements in our array instead of using 6 because we're getting rid of one of those. We're changing one of the vec3s into a vec2. However, the offset's still going to be the same because this still has 3. The text chord attribute location, whoops, need to change it there as well. This is also going to only have 2 elements. So let's see, I think that was all the times that we actually do that. Yep, it is. Great, so now let's change the actual vertices. Now, what I'm going to be doing is you can see that when I formed these, I said for the top, y is always going to be positive 1, and then x and z are going to alternate between -1 and 1 in a pattern, just like this. For the left, it's going to be -1 on the x, for the right, it's 1 on the x, front, it's 1 on the z, and so on. I always pick one constant, and then the other 2 vary. So what I'm going to do, because I'm really lazy, and I don't really feel like actually figuring these out vigorously myself, is I'm just going to say the one that is constant, let's ignore that, but these other 2, they obviously alternate between coordinates between different sides on one of the coordinate axes, so between x and z in this instance. So let's just map the x and z to u and v respectively. U, v. And we'll say that -1 is the 0 side of u, and that 1 is the 1 side of u, and likewise for z and v. So for here, because this has an x value of -1, we'll give it the u value of 0, and likewise for z being -1, we'll give that a v value of 0, and we'll repeat that process 0 and 1, because this has -1 and 1. This one will be 1 and 1, and this one will be 1 and 0. And I am just going to skip all the boring parts where you watch me replace all those values manually by pulling this from the notes that I made earlier. So you can see if I pull that back, if I copy and replace enough, you can see that none of these values on the inside are changing, it's just the UV values that I'm swapping out. Great. Let's see what else we have. So if I were to load it right now, it would render, but it would still be black, and it would complain that there's no texture loaded. Yep. Well, it's not complaining that there's no texture loaded. By default, I think it just uses a black texture in all of the texture registers. So, next step, let's load that texture, actually. And we're going to be doing something similar to what we do in this whole create buffer step. So why don't we do it right after we create the buffer, in fact. Create texture. So a texture is also an array, or a buffer object that you do on the graphics card. So you create it in a very similar way that you create the vertex buffers. Box texture equals gl.createTexture. You also bind it in a very similar way. gl.bindTexture, gl.texture 2D box texture. And then what I'm going to do at the end here is I'm just going to unbind it. I should have been doing this the whole time, unbinding all the buffers after we load them in. I haven't been. I don't have a really good reason. I'm just going to do that for good practice to unbind it from the graphics card. So if we do this, great. So now it's giving us the error. There is no texture unit bound to unit 0. Cool, so now we've bound a texture. Let's give it those parameters for the wrapping and filtering that we saw before. The way to do that is you do gl.text for texture parameter I for integer, gl.texture2d. All of these, like gl.everything in caps, these are just integers that OpenGL knows how to handle, and we're using named constants for them because we're good programmers. So the first one is the texture wrap, and for whatever reason that I can't explain, the wrap is in S and T instead of U and V. S corresponds to U, T to V. I don't know why they do that, but they do. Where was I? Texture wrap, S, and then GL dot, we are going to use, I think it was mirror, yeah, or no, it was, what was the name of it? No, not Steam. As much as I'd love to play video games right now, that's not what I'm doing. Clamp to border, that's right. Clamp to, and it looks like it might be called clamp to edge in WebGL, so we'll use that. gl.clamp to edge. Great. Let's actually just make sure. We'll look that up in the documentation. Text parameter I. So if I do that, MSDN. Yes, clamp to edge. That's what we want to use. Great. So let's do the same thing for our texture T coordinate. And then let's set our sampling really quick. gl.text parameter I, gl.texture2d, gl.texture min filter. And let's use linear. In this tutorial, it will not, the differences will not become immediately apparent. Great. Let's make sure I got that right. Texture min filter. Texture filter to use when rendered smaller and when it's done larger. Yes, those are the two that we need. Max anisotropy, whatever that word is. Oh, yeah, that's only if you're using a certain extension, which we are not using any extensions in these videos. Cool. Great, so after all that, should be able to refresh it, and yep, it's doing the same thing. No texture bound. So let us now actually add the information. And the way that we do that is with a gl.textimage2d, gl.texture2d. I'm going to cover this in just a second. I am going to point out really quick before I go on, all of these things are done on the texture, but they can be changed later, for example, like in the render loop and all that. Anyways, so the textimage2d is what we use to actually specify what information the texture is going to use. And let's look it up in the documentation, textimage2d. So the parameters that this expects is what type of texture we're using. We're using a texture 2D. You don't really have to worry about any of those. The level of detail, which for us is just going to be 0. The internal format, RGBA, because we have a red, green, blue, and alpha channels. The width, height, and border you don't have to worry about. As you can see, they don't have this in next to them, so you don't actually need them. They're all optional parameters. Yes, this is only used when a uint array or a float32 array for pixels is specified. We're not doing either of those things. So the format is going to be the same as internal format, whatever this one was, RGBA again. And then the type is going to be, I believe we use unsigned byte for this because it's 8-bit per channel for red, green, blue, and alpha. If you want to use an extension for floats, you can use that as well, or you can use 16-bit colors in any of these formats. So, gl.textimage2d. Oh, and then the very last thing is what actual pixels. And we can pull this in straight from an image tag, which is what I'm going to be using in all of my tutorials. So let's specify those. Level of detail is 0. Format is RGBA twice for whatever reason. We're using unsigned byte. And then here, this is where we get the image tag, which actually has our texture that we want to use. So that is create image. So I'm just going to say document.getElement by ID create image. So now if we go back, we're going to run into a fun problem. This is a security error. This is something that Chrome does, and I believe Firefox does as well, where it refuses to load images that do not come from the same origin. And the reason for that is because these shaders actually run on your GPU. So this is usually the browser gives an interface to the web page for how it wants to interact with the operating system. So it can read the mouse and stuff like that, but it can't actually execute programs very easily. WebGL is an exception. It actually runs these programs on your graphics card, which is a security threat. I can't think of anything off the top of my head that might cause problems, but it's just really good practice to, if you're allowing unbridled access to the GPU through something, to any piece of hardware, to be careful with security. So we're not letting it use this because for whatever reason it counts everything coming from a file as coming from cross-origin. And what I mean by cross-origin is, say if your website is mywebsite.com, you won't be able to pull any images from like sketchywebsite.com. You have to pull them from a mywebsite.com address. So to solve this problem, I'm sure many of you have seen it if you've done any OpenGL before, and you've done this kind of, or any WebGL before, and you've tried to experiment with this. This is a very common problem. Let's go into PowerShell. It's a lot easier on Linux, but I'm using Windows. Let's go into the directory. This is game programming, Indigo CS. And yes, that's the actual folder. So there's two options that I'm going to talk about right here. If you have Node installed, Node.js is a server-side JavaScript that you're able to do. If you have Node and npm installed, there is a package that you can install globally called HTTP server. And what this allows you to do is this allows you to just host a small little HTTP instance that will only serve static files. So if I were to run that, I already have it installed. You can see it starting up, available on whatever my IP address is, 8080. So localhost 8080. And it should not be showing the image quite yet. I don't think I have another server running. Let's just make sure. I'll add some text to that. Oh, I see. I think it was caching. There we go. Okay, so this is more what I was expecting. Yeah, I think it was caching from when I started this video. Yeah, I probably should have exited that properly. So let's try to get this set up right. So if I refresh this, server should not be running. Server is now running. Server is now running. Okay, cool. So that's option one, is do it that way. Option two, if you have Python installed, is you can do python-m simple HTTP server, and it will do a very similar thing, but it will start on port 8000. And you can see it's doing the same thing, where I'm loading it, and it's no longer complaining about the security error. We still have a couple of steps that we've missed, which is why it's black, but at least no security error. For some reasons, I have had some problems with the Python one, so I'm going to be sticking with the npm installed HTTP server. Great, so I can get rid of this test right there. Great. Cool, so the last thing that we need to do now is we have this texture that's all set up. Actually, I'm going to take a step back. So with our vertex buffers, if you remember, we had to create the vertex buffer, we had to bind it, we had to specify the data, and then finally, all the way down here, right here, we had to associate the shader variables and enable them with the vertex buffer. So we had to say the position is going to be from that vertex, or it's going to be from the active buffer, it's going to use this many elements. With textures, all we have to do is we have to bind the texture back to the graphics pipeline, and then we also have to specify which sampler slot we're using. If we were to have multiple samplers, This one would use slot 0, texture slot 0, this one would use texture slot 1, and so on, just in order that they appear in the shader. So let's go down here, and after we clear the buffer, but before we draw the elements, let's bind those values. So we'll say gl.bindTexture, gl.texture2d, box texture, and then gl.activeTexture, it's going to be gl.texture0. And this line right here is saying whatever texture is active, I want to bind that to the 0th sampler slot. So if I refresh this now, it should, bada bing, bada boom, it works. Everything is great. That's awesome. And somehow, it looks like we didn't run into the problem that I was running into when I was creating the proof of concept of this video. Sometimes it'll complain if you're using a non-power of 2 dimension. So if it does that, resize it to something power of 2. 512 by 512, 1024 by 1024. I believe the reason it's not complaining anymore is because one of these options, I'm not sure which one it is. Okay, so apparently these two options make it so it doesn't really care as much that it's not power of 2. This is the error you might be getting. So, for whatever reason, clamp to edge seems to like that. Great, and that's really everything I have. I don't have anything else on texturing to show in this video. I might do some more advanced texturing later, so perhaps bump mapping, there's you can blend textures together, that kind of thing. But for now, I think I'll be done. So at this point, like I said, I'm just going to keep creating these tutorials until I get bored of it. Let me know in the comments if you want to see anything specifically. Hope you enjoyed the video, and check out the source code on GitHub.